Sounds
Yeah,
mean.
They should make a car called the Elimination. It eliminates the.
That sounds really bad. I wouldn't buy a car that sounds like Eliminate.
Okay.
I would
Deer as you
eliminate.
drive down the road.
The
Eliminates you
elimination method works when you have two systems and like these look the same. The two y's in there look the same, or the two x's look the same. Okay? What you want to do in this case is you want to take, get that smaller before I erase something really
Both
important.
equations by -3.
You want to take and make one of these negative. It really doesn't matter which one, because when what you're going to do is you're going to add these equations together, okay? And you want to eliminate either x or y. So in this case, I'll do something. I'm going to decide to make this 3 negative. And legally I can do that only if I change all of them. So if I change all of these across the board, I'm still good. Then I just start adding these together. Well, if I add these together, I get 3x. These eliminated.
0.
If I add these together, I get
-6.
-6. So I got 3x equals -6, so x is -2. Cool. I already know my x.
But are they gonna give us problems like that very often?
Oh, I don't know. I never taught about this before.
Yeah, because elimination doesn't always work though.
Yes, you can always make elimination work.
Well, yeah.
You have to times it all by like 2 or something.
Right.
Or all that.
Right. Okay? Now my hard part about elimination though is figuring out what the y is. What's the other one? Well, so you have to go back, and it doesn't matter which one of these you choose. You can choose any equation that you want.
Just plug that
But
2
you
in.
gotta go back and plug that -2 in for x. So if I plugged it in right here, that would make that -10. And then if I added 10 to both sides, I would get -9 equals 3y. And so y would equal -3. What kind of a solution do I have?
Independent and constant.
Consistent.
Consistent.
I was gonna
It's
say
consistent. It's consistent and independent. That's right. That's the elimination method. Let's try another one. The 5a. Oh, look at that's beautiful. Look at
That is too perfect.
that. Add your equations together.
We can-
6x eliminate
Done.
equals
Oh, 6.
-6. -6.
Yeah.
So x equals
0.
-1.
Right.
Right? So what's -1?
X.
X is -1. So how do you find y?
Put -1 for x.
You go back in to either one of these. Which one do you want to use?
The bottom one.
Okay, and you're going to put -1 here.
You get
So that
-2.
makes -2. So that means you're going to
Add
add 2, which would be 18. 3y is 18, so y is 6. What kind of solution do you have?
Consistent and independent.
Consistent, independent. What about 5b?
I have a
We
question.
have to add.
What if they put like
Add it.
you know it says equals -22
Yeah.
equals
Yeah, but it's like
16?
Yeah.
So you're adding.
Multiply by
Could
-1.
those two numbers be the same?
Sure.
Then they would be right on top of each other.
No. No. Mm-mm. You mean if I change this to a -12,
Yeah.
would those two numbers be the same line?
Like
No.
because you have stuff before, but how can they equal the same thing if they're different?
I guess I can think of like 7 plus 5 is 12, and 6 plus 6 is 12.
Okay.
So just because I got the same 12 doesn't mean this is the same.
That's true.
Okay? That's the best way I know how to answer that right now, off the top of my head. Okay. What looks like I want to do here?
The third one.
Well, what looks like
Oh,
I
like, oh, okay.
You have
I
to
want
change
to.
all the signs.
Okay, and which one?
The top one.
It doesn't matter which one.
Doesn't matter, but she said the top one, so okay, I'll do the top one. Then what do I do?
You add them
Do
together.
your math.
Add them together. What do I get?
Negative
Negative 2x
2 equals negative 4.
negative 4.
So x equals
Neg-
positive 2.
X equals 2.
2x. I mean, x is 2.
X is 2.
So you can put 2 in for an
The
X
bottom
and the bottom
Okay,
one.
so that makes this
8.
8.
So subtract 8.
Subtract 8.
You get
Subtract
negative
8.
20.
Negative
You
20.
get 4.
Or
4.
negative 5 divided by negative 5, so I get 4. What kind of a solution do I have?
Consistent.
Independent.
Consistent and independent. Okay. And just because we have exactly the right amount of time left, let's go ahead and do this last one. What about it?
We're gonna
Yeah,
Just
add
do
them
your
together.
Add them together. Eliminate.
math. Negative 3.
Y.
equal
6.
Yes.
Negative 2.
Y equals negative 2.
negative 2.
Negative
Put it in
2
the
is
bottom one.
Y.
Put in the
Bottom one.
Negative 12.
Negative 12.
Add
Add
12.
Add 12.
14. Or 16.
16. Negative,
Yeah.
Yeah.
right?
And then rip off your 2.
Negative 2.
You
8.
get positive 8.
8. Now?
Independent and consistent.
No, yeah.
Good. It's independent and consistent. Let's just try this. Let's see what happens if I put in 8 for x and negative 2 for y. If I put in 8 for x, I get 16, and if I put in negative 2 for y, I
Positive
get plus 18. And does that equal 34?
Yeah.
What if I put in 8 here?
Negative 16.
Negative 16, and if I put in negative 2 here,
Negative 12.
I get negative 12, and if I add them together, do I get negative 28?
Yeah.
That's the only time I can use that in both of those, and they'll both be true. I could never do it with any other ordered pair. It's the only time.
Cause would they ever give us one like where it's like two absolute values and there's like two spots where they would intersect?
Yeah, that's a crazy question.
Sure. Yes, and a parabola. Yes.
Okay.
Yes.
Is it possible to have a sideways absolute value? Or a parabola?
Yes. Yes.
I
Yeah.
thought it is, but how do you do that?
I don't know.
I've been trying to figure that out.
We'll just draw one and then plug those points in.
See what it is. We'll learn that. We'll learn it.
Are you still making your video?
Yes, I am. We also will have a system of 3 equations.